All right, so this is going to be part 2 of our video for the review of not the exam, but the review of our material that I posted. So let me bring it up now. So we finished with number 5 last time. And so let's take a look at number 6. So number 6, and I'll bring up my whiteboard here in a second, but we'll go ahead and take a look at number 6 and pause it if you need to, but I'm just going to write it on my whiteboard right now. And so what we have, if I can bring up my, okay, there we go. So what we have is we have some sort of charged object in an electric field, and it's being attracted. It's being pushed to the right. And so we have some length of string here, then we have a charged object right here, and then we have an electric field that points this direction. And this is our electric field. So keep in mind, electric fields point from positive to negative. And so if our object is being attracted to the right, that means it must be a positive charge because it's being attracted to the negative charge. And so therefore, right off the bat, I can say, whatever answer I come up with, it has to be a positive charge. So let's take a look at what forces are acting on it. Well, we have, so this is our object. We have a tension pointing up like this. We have an electrostatic force pointing like this. And then we have a mass times gravity. We have a gravitational force acting like this. Because this tension's at an angle, let's decompose it into its component parts and then figure out how the forces balance. They do balance because it's not accelerating. And so we can say that, okay, the electrostatic force is balanced by this tension in the x direction, and the weight, or the gravitational force, is balanced by the tension in this direction, tension in the y direction. This will be our angle theta right here. And so what are we left with? Well, we're left with Ty is equal to the gravitational force mass times gravity. And then we have Tx equal to the electrostatic force Fe. What is Tx and Ty? We'll take a look at this little vector diagram. Tx is going to be T sine theta, and Ty will be T cosine theta. And so we're left with T cosine theta is equal to mass times gravity, and T sine theta is equal to, I'm going to write QE instead of the electrostatic force, because remember, we have, we can say that the electrostatic force, this Fe, is equal to KQ, this is one way to write it, KQ 1/2 over R squared, that's one way. Another way to write it is it's the charge times the electric field. And for us, this is going to be useful to us because we want to solve for one of those charges in terms of the electric field, in terms of what we're given. And so if I look at these two equations, I say, okay, tension is in both of them. I can eliminate that tension and make this solving a little easier. And I can eliminate that by just dividing the two equations. And so when I do it, I am left with sine theta is equal to QE over cosine theta. And this is also over mass times gravity. And I can simplify that a little bit. I can say that sine theta over cosine theta is tangent theta. I can isolate the Q by bringing the mass gravity over here and then dividing through by the electric field. What am I left with? Well, I'm left with the, make sure we can even see here. What am I left with? Well, I'm left with Q is equal to mass gravity times tangent theta all over the electric field E. And so our answer is a positive charge with this value. Well, let's go back to our choices here. Well, and that would correspond to B, positive charge with magnitude mg over E times tangent theta. All right, so number 7. Number 7 says we have 2-point charges, a +2 microcoulombs over here, a -1 microcoulomb over here. Where is the electrostatic force, or where would you put it so that its electrostatic force is 0? Well, think about which way the electric field is going to point for each of these charges. In region 2, the electric field is going to point away, because remember the electric field points in the same direction that the electrostatic force points. And so in region 2, well, we're going to have electric field lines coming out from this positive charge, so they'll point to the right. And they're going to, for the negative charge, the field lines are going to point towards it. So in region 2, all of our vectors are going to be pointing towards the right. And so there's no way, you can't put a positive charge in region 2 without it just being pushed by this positive charge here and being pulled by this negative charge here. So region 2, right off the bat, we can say there's no way you can find an area where the net electric field is 0. It's either region 1 or region 3. Well, think about the fact that these two charges have different values. And if I want to find a spot where the net electric force, the electrostatic force is 0, and we're putting a positive charge right there, it needs to be far away from that positive charge. This is the way I think about it, is it needs to be farther away from that positive charge and closer to that negative charge. So in other words, if you put it somewhere in region 1, the electric force due to this negative charge, it's far away from it. And so therefore the electric force due to this negative charge is going to be overwhelmed by this positive charge that's closer to it. So there's no way in region 1 where you can find an area where a positive charge isn't going to be repelled more than it's going to be attracted to this negative charge. So therefore our answer is region 3. It's region 3 because it's going to be closer to this negative charge, and because this negative charge has a smaller charge, because this negative charge is smaller than this charge, the electric force is going to, it can be 0 in some area over here in region 3 because it's because the fact of, well, for the same reasons it couldn't be 0 in region 1. All right, so the answer then is region 3. And by the way, if these two are equal, think about if these two had equal values. So instead of +2 and -1, you could think about, well, what if this one's +1 and this one's -1? Well, in that case, there is nowhere that you could find an area where the net electric force is 0. So just something to think about. All right, so number 8 says we have a diagram at the right showing two charges of +q and -q. Which of the labeled vectors best shows the direction of the electric field at point X? And so let me bring up my little board right here. And so at point X, we have two different charges. Wants to know what the electric field vector looks like at point X. Well, I'll try to draw this as best as I can, but these two sides, well, that wasn't very good, but these two sides right here are of equal length. And so if these are of equal length, and this is a positive charge, this is a negative charge, if these two are of equal length, we know that the hypotenuse then is greater than either of those two sides. And so therefore, this positive charge, this is our point right here that we want to consider, therefore this positive charge is going to have a vector, force vector that looks like this. But this negative charge is going to have a force vector that's longer. It looks like this. Those aren't really to scale, but the point is that this negative charge is going to experience a greater electrostatic force. All right, let me be clear. At this point right here, this point is going to experience a greater electrostatic force attracting it to this negative charge than it would this positive force over here because it's closer to the negative charge. So therefore, all right, so what do we do then? Well, we do a little vector addition. If you remember, we always draw vectors tip to tail. And so what we should really do is we should start out like this, and then the other one points straight down like that. And therefore, our vector, our actual vector, is going to point somewhere in that direction. So if I go back to my problem here, the answer would be 2 then. It's going to point somewhere in that direction. You can eliminate 3 and 4 right off the bat, and then 1, well, you can eliminate really all of them pretty quickly, but the answer is 2. So it's B. All right, that's our review.